Okay, so in EEG, we can't necessarily localize a response to a specific area. So other technology like fMRI is great for this. EEG's strength is mainly in the temporal resolution. So we can see what's happening when it happens down with millisecond accuracy, but we can't necessarily find a generation point for electrical activity. There's, there's some disagreement on this. If we have an EEG cap with 256 electrodes, a dense array just crammed together on the scalp, we will have a better idea of whether the electrical activity is coming from like the frontal lobes versus the temporal lobes. But you, again, couldn't get down to the deeper areas. You couldn't say that this electrical activity was generated in the amygdala. And yeah, so it would be a very difficult thing to do with EEG. But there's similar technology out there, such as single cell recordings, which is mainly done in animal models, which is basically inserting a needle down into a part of the brain and recording single neuron activity. That will give you more specificity, but of course it's invasive and dangerous, so it's not quite so popular. And deep stimulation electrode arrays are also possible. And people who are having brain surgery to cure intractable depression, for one, can actually have the skull opened and an EEG-like array put on the brain. And from there are tiny needles that will be going down that they can later use a button to deliver current to certain areas to try to stimulate the release of serotonin or something for depression. So that is a related technology, but EEG, no, can't do that.